So, my name is Krish Gandhi. This is my Physics 2 Lab 2 video. So, the introduction of the lab was mainly we're enhancing Lab 1 data by making a more advanced computational model for the electric force and the charge tape. So, we're making it better by instead of representing the tape as a point charge, we're doing it as a line of charges to account for like the distribution of it itself. And some of the main findings of the charge on one piece of tape was 2.5 to the -8 coulombs, and charge magnitude is over twice that calculated from the charge. So as you can see, from the computational approach, the tape is modeled as a continuous line of charges, so we can accurately find the electric force and distribution. And the setup is basically the same from lab one. We're mainly just updating like the code and things like that for this lab. So key assumptions is that the charge distribution is uniform and all the U-tapes have like identical charges. And lastly, air resistance is kind of disregarded. So these are the main principles that we see in this lab. We're looking at the Coulomb's law / the electric force, the electric field of a distributed charge, which is just the sum of the fields, the gravitational force, F equals mg, and then Newton's second law, and then all the representative formulas are there. So the experimental model, the setup looks at the system, which is just the U-tapes, the surroundings is the base tape supports and the environment. And the initial state is that there's no electrical charge present. So the procedures, we have two U-tapes, A and B, and they're prepared by rapidly peeling them from a base to create charge. Tape A was positively charged after being attracted to negatively charged pen, and tape B was suspended between two rulers. So when you move tape A near it, the tape B would like levitate from repulsion because of like charges. And then the separation between A and B was recorded. So here's our data from this lab and lab one. So obviously we have the tape length, the mass, the width, and the separation distance. All those values are right there. And then the lab one results from point charge. We saw 1.96 times 10 to the -3 newtons as the magnitude of the electrical charge / gravitational force. So here's some of our code. Yeah, we can just take a look at that, I guess. I'll move the camera. Okay. Here's some more code that we used to discover different things, showing our formulas and the line axes and all that. And here's more. Okay. So the discussion is for the comparisons and observations, discrepancies exist basically between the model and real life results. In reality, gravitational and electric forces, they're not perfectly balanced, but you can have extra forces that influence the tape. And then modeling the tape using finite segments as a line instead of point charges will create a more accurate representation of the lab we did, because originally we used it as a point charge, but this one we're changing it to a line of charges. And then some errors could be variations in charge that might exist in real life through like different types and pieces of tapes. Mishandling the tape could also be another reason, or maybe even extraneous variables for such like air resistance and environmental factors. Okay, and then continuing discussion is what if the tape was modeled as a single point charge similar to the previous lab? Well, here's the values. As you can see, the line charge gives a much larger value, showing it's more like accurate because it's taking into more things account. And then why do they differ? The point charge simplifies tape's distribution, and the line charge is more accurate because it accounts for the distributed nature of the charges. And then which value is more likely to be real? The line charge model, basically, because it's more reliable and reflects the actual distribution of the tape rather than simplifying it with point charges. And that's it. Thank you.